Hi class, let's take a look at example 3. Now for example 3, we're going to check if the lines are actually skewed. Skewed means that they have no intersection, and then here you can see what the actual picture is. Now in any case, you first have to check if they're parallel. Now if you're checking for parallel, this one's going to be actually very easy because you can see that your vector t cannot be expressed as a constant multiple of vector s. So in this case, let me just say that if v, which is equal to t, and in this case you have 1 comma negative 1 2, and let me label this one as v1, and then technically v2, this is equal to the vector s, and vector s is 0 1 1, then we can say not parallel since v1 cannot be expressed as kv2, where k is an actual constant. So you have to check at least that they're not parallel. In this case, the constant that makes it easy to identify is, well, your x value, which is your 1 and 0. Now, if that wasn't clear, you needed to evaluate the cross product and verify that they don't have the same vector. Okay, next you're going to check to see if there's actually an intersection. So next intersection. Okay, there's going to be an intersection if you look at the x's. And then in this case, let me just select the values of the x's. And in this case, you would have that 1 plus the values of t. This is equal to 2. Actually, just the values of 2. Since we're looking at the second line, and then your values of the y's. And then the values of the y's, we're not looking at, well, the second portion, which is going to be a 2 minus t. So technically 2 minus t, it's equal to, well, you only have an s on the second line. So I'm pairing up the actual x value, which is 1 plus t, actually, sorry, minus t, and this is equal to s. And then the last one is going to be your c coordinate. Okay, as we look at the c coordinate, you're going to have that 2. Okay, so your c coordinate, it's going to be equal to 3 plus 2t. And this is equal to 1 plus s. So 1 plus s. Now, you have to be very careful here because you may find out that there's an intersection and you have to technically check both. So if you subtract 1 from 1 plus t, you're going to find out that t is equal to 1. And then if we plug it in for any of the equations, let's plug it in. So evaluate t is equal to 1 into the second equation. So you're going to have that s is equal to 2 minus t, or the values of s is equal to 2 minus 1, or s is equal to 1 as well. Now, if you're using any of these, in this case, let me use t is equal to 1. You're going to find out that your x value, in this case, your x is going to be 1 plus t, or technically 1 plus 1. You're going to find out that that's 2. Your y value, it's going to be 2 minus 1. So 2 minus t, or 2 minus 1, which is 1. And then your z value, it's going to be 3 plus 2t, or 3 plus 2 times 1, which is going to give us 5. So in this case, you would have concluded that your coordinate point happens to be 2, 1, 5. So 2, 1, 5. Now here's the problem. You have to check, since you're assuming there's an intersection, that when you plug in your second value for s, which in this case we're getting 1, that you also have the intersection. So let me just say evaluate s is equal to 1, and you're going to have that your z coordinate is equal to 1 plus s, which is equal to 1 plus the values of 1 or 2. So here you have that the intersection happens to be 2, and this in this situation gives us a contradiction, because we already found that your c coordinate was 5. So since we checked and the lines are not parallel, we assume there's an intersection. So here we're checking to see if there's an intersection. We find a contradiction on the intersection. In this case, we have to assume that the lines are skewed, and that means that they're not intersecting at any point in space, and they're different lines. So let me just write it up. Let me just rewrite it as contradiction. In this case, the lines do not intersect, since we found that if t is equal to 1, your z value happens to be 5, and that is not equal to 2 when s is equal to the values of 1. I'll just say hence there's no intersection. We also checked the lines are not parallel. And then the final portion, we're going to say that, well, we can conclude the lines are skewed. And in this case, this is the only conclusion. Once again, we are asked to check if the lines are skewed. You first have to verify that they're not parallel. Also, if you find an intersection, or you're going to try to find an intersection, you have to be careful with the intersection, because you can accidentally conclude that you have a point, and in this case, this point provides us a contradiction, and you're not going to find the contradiction until you plug in the second point, or in this case, your solution to the s vector is 1, and that's where the contradiction appears, which gives us that, well, unfortunately, the z coordinate is incorrect. That's actually it for this one.